Dr. Rajeshri Dua, Assistant Professor, Department of Electrical and Electronics Engineering, Swami Vivekananda Institute of Science and Technology. Today, the topic of discussion is one of the basic topics which is needed for basic electrical, that is first year students, as well as it is required for the second year students who are going to learn about electric machine 1. The topic is magnetic circuits and magnetic fields. Now magnets are something which are highly fascinating, and we all know what magnets are. So dating back to the Greek city of Magnesia, what happened? Many natural lodestones were found, and these lodestones were capable of attracting iron particles or magnetic materials. So magnet is something which can attract iron and other magnetic materials towards itself. And this property by which the magnet attracts these magnetic materials towards itself is known as magnetism. And the entire structure of electric machines, transformers, DC motors, DC generators, electromagnetic relays are dependent upon this magnetic property and another property which is known as electromagnetism. So next we classify what are the different types of magnets. So magnets are classified into two groups. One is natural and the another is artificial. So what are natural magnets? Like magnetic ores, lodestones, which are actually already present in nature, but their magnetic field strength is quite weak, and therefore we cannot use it for actually practical applications. And that's why we are moving on towards the artificial magnets, which are made from iron, steel and any other alloys by passing electric current through the wire wound around the iron piece. And this is what is known as electromagnetism, that is we are passing electric supply or electric current or giving a potential across this iron or steel components in the form of a solenoid so that they become magnets, and this property is known as electromagnetism, and those artificially formed magnets are known as electromagnets. Now, what are actually the applications? So permanent magnets are example hardened steel or alnico, which retain their magnetism for durations even after the magnetizing force is removed, and their applications are found in earphones, loudspeakers, small DC motors. And temporary magnets, so as they say, permanent magnets means they are retaining their magnetism even after the magnetizing force is removed, and temporary magnets are like soft iron or nickel, which retain their magnetism as long as the magnetizing force is applied, but they are more important than permanent magnets, and these are widely used in the field of electrical generators, motors and relays. So temporary means as long as the force which is creating the magnetism is present, it will retain its magnetism, and once the force is removed, it will not retain its magnetism. So temporary magnets are widely applied in the field of electric generators, motors, relays. Now what is a bar magnet? So this simple representation, a magnet in the form of a bar. And we know that whenever a magnet is present, there will be one north pole as well as a south pole. So magnetic lines of force, they move outwards from the north pole and they get inwards into the south pole. So from the north pole to the south, and they are actually bulging outwards. So this is actually the representation of the magnetic lines of force produced by a bar magnet. So what are its properties? The properties are that the magnetic lines of force are actually forming closed loops, and these lines of force, they never intersect each other. They start at the north pole and end at the south pole, and they bulge out sideways due to lateral pressure. And also lines of force that are in the same direction, they repel each other. It's like poles repel and unlike poles attract. So these properties are found in the magnetic lines of force created by a bar magnet. Now, what are the properties of magnets? Properties of magnets, it's very simple. We all almost know, but still. So the magnets basically exist in dipoles. Means there will be one north pole as well as a south pole. They cannot exist in monopoles. So magnetic monopoles, they do not exist. They always attract iron and its alloys, means magnets actually attract all materials which are having magnetic properties. A magnetic field is established by a permanent magnet when we are supplying electric current through it. As we have already said that like poles repel and unlike poles attract. A magnetic substance, this is very important. A magnetic substance becomes a magnet when placed near a strong magnet. This phenomena is known as magnetic induction, which is predominantly found in transformers also. And what we can say that the magnets can be demagnetized by heating or mechanical germs. What happens is that inside the magnet, the smaller magnets are present. So once they are oriented, the magnetic field strength is high. But once they become disoriented, a magnet can be demagnetized. Even a permanent magnet over the years can also get demagnetized. Now moving on to magnetic circuits. So what are magnetic fields, what are magnets? It's already said. But our thrust will be in understanding magnetic circuits. So there are certain terms which needs to be explained here. The path followed by the magnetic flux is known as the magnetic circuit. So magnetic circuit and magnetic flux. So the path followed by the magnetic flux is known as the magnetic circuit. But there are some important terms which we need to know. These important terms are MMF, that is magnetomotive force, magnetic flux, reluctance, permeability and inductance. So what is the purpose of study? Why we need to study all these terms? Because they are essential terms in order to understand the design analysis and the application of electromagnetic devices like transformers, like electric machines, etc. So if we do not have an idea as to what these terms are actually concerned, we cannot actually know about the application of magnetic of elements or of devices which are actually meeting this principle of magnets. So these are like transformers, EM relays, electric machines, and generators or motors. So what is MMF? The first term. The full form of MMF, it's very simple, it's magnetomotive force. Another important thing should be kept in mind is that there is a strong analogy between magnetic circuits as well as electric circuits. So students know that in electric circuits we have one term which is known as EMF, that is electromotive force. So MMF is analogous to this EMF only. So what is the definition of EMF? So magnetomotive force is actually defined as the work done in moving a unit magnetic pole once around the magnetic circuit. That is, once we are moving the unit magnetic pole to the magnetic circuit, the work that is done is nothing but the MMF. Mathematically, MMF can be written as the product of the number of turns of the coil as well as the current passing through the coil. And as I have already said, this is quite analogous to the EMF in the electric circuit. Now let us say that this is a bar magnet. So this is the north pole, this is the south pole, and there are these wires having a number of turns, say N, and whenever we are actually applying a potential, a current is flowing. So what is magnetomotive force? It is the multiplication of the product of this N, that is the number of turns, and the current, that is I. So what will be the unit of MMF? It's simple, the unit of MMF is ampere turns or AT. So MMF is clear. Now we need to know about the Ohm's law for magnetic circuits. We know what is actually the Ohm's law for electric circuit. That is V is proportional to I, V is equal to I into R. So what is Ohm's law for magnetic circuits? For that we need to know a little bit about certain terms. So I will come to it a little later. Now moving on to the next element, that is magnetic flux. MMF is clear. So what is magnetic flux? Magnetic flux is actually the measure of the number of magnetic field lines passing through a given closed surface, and it provides the measurement of the total magnetic field that passes through a given surface area, and its symbol is given by this phi. So magnetic flux can be measured by an instrument which is known as the flux meter, and the SI unit of magnetic flux is known to all of us, that is, it's given as Weber. Now moving to the properties, I have already told about the properties. I've already told about the properties of magnetic lines of force. So let's move to the next part. So what is reluctance? So we have already known about MMF, that is the magnetomotive force. We have already known about the magnetic flux. Then we need to know about another important term which is known as